All right, so today we're going to finish up Law of Sines and take a look at Law of Cosines. Okay, just as a reminder, that's the Law of Sines. Okay, sine of alpha over A equals sine beta over B equals sine gamma over C. Okay, and that law is used to solve three types of triangles. You use it for angle, side, angle. You use it for angle, angle, side. And you use it for side, side, angle. Now, the first two, okay, when you solve problems that are those type, you only get one solution. Okay? When you solve the side, side angle, I underlined it because that's the one you have to be careful. There's three cases. You could get 0, 1, or 2 solutions. On the test last week, you guys did the one solution. So today we'll look at a 2 solution, a no solution, and see how those work. Okay. Does anybody remember from looking at the table, if you don't want to make the diagram, how you can tell that this is a law of sines problem? Or you can draw the picture and see which of the three types it is. Yeah, if you've got a row with everything in it, that tells you that it's a law of sines problem. What tells you that it's the case you have to be careful about the 0, 1, or 2 solutions is you have a row with nothing in it as well. And you have no way to find anything in that row until you find something else first. Okay? Why can't you use the Pythagorean theorem to get C? Yeah, we're not dealing with right triangles. If it happened to be a right triangle, then you could. But most of the problems are going to be oblique triangles, okay? No right angle. All right, so out of the three things, when you have this kind of problem, you are forced to find beta first. Okay? So we're going to find beta. Okay, and this is going to be just like a problem we did last week. It's just going to start out the same way. Okay, what can I put on the left? Amanda? Sine 35 over 6. And then on the right, I have to use the second row because I'm missing everything in the third row.
Sine of beta over 8.
Sine of beta over 8. And then to solve a proportion, how do we do that? Cross multiply, or even in this case, all we really need to do is multiply each side by 8 to get sine beta by itself. So we get 8 sine 35 over 6 equals sine beta. Now, we want beta. We don't want sine beta. So how did we get rid of sine? Dave?
Inverse sine.
Yep. Take the inverse sine of what's on the left and on the right. Now we type that in and see what happens. If we get an error, that means it's a no solution problem. If we get a number that comes up, then that means we have at least one solution, and we have to check for the second one. So second inverse sine. So 8 sine 35. It's important you close the parenthesis. And what do I need to fix on my calculator? Yeah, I'm in the wrong mode. Okay, all these problems and section 8.2 are all in degrees. All right, so this is not a no solution problem. There's at least one answer for beta right there. 49.886. Now, what other quadrant is sine positive in? Where else could you get a positive value? Quadrant 2. I just got a quadrant 1 answer. Now I need a quadrant 2 answer. What do I do with 49.886? Yeah, let's subtract it from 180. So if there's a second answer, it's 130.114. But I have to check if that one works. What do I mean if it works? What has to work here?
You add that angle with the angle that you know it's like above 180 or something like that.
Yeah, I was given a 35. So I have to see if this angle that I just found would fit with the one that was already given. Would they both fit? Yes. Okay. If the given angle was something like 70 degrees and you got 130, then that one would be too big to fit. That's what happened on the test. All right, so 130.114 does work. So what I'm going to do is call it beta 1. and beta 2. And what else does that mean is going to happen in the problem? There's going to be 2 gammas and 2 c's. So at this point, it's not a harder problem, it's a longer problem. We just have to do every calculation twice. So just to make it clear, this angle, actually, you know what, let me, yeah, I guess I can do this. That angle, and that angle are all in one triangle. Alpha, beta 1, gamma 1. This angle, and that angle are all a second triangle. Alpha, beta 2, and gamma 2. Okay, alpha is in both. All right, so how would I figure out gamma 1 based on what I know?
Add together alpha, beta 1, and subtract alpha.
Yeah, just take beta 1, add it to alpha, and subtract that number from 180. So gamma 1 is 95.114. And now how would we get gamma 2? Yeah, we're going to take beta 2, 130.114, alpha, add them up, and subtract that from 180. 14.886. And now I finally have a piece of information in the last row to solve for C1, and I have another piece of information that I can solve for C2. So besides the last row, what other row am I going to use to solve for C1? Yeah, we're going to go back to the row that was given. So let's solve for C1. And we're going to do sine 35 over 6 equals, and how would you solve for C1? Yeah, sine 95, 114 over C1. Sine 95, 114 over C1. And now we cross multiply. And for C1, you're going to get 6 sine 95, 0.114 divided by sine 35. Any questions on how you would type that in? No? Okay, you just type that in. And now we're going to do it again to find C2. What's going to go on the left-hand side when I find C2? Okay, so I'm going to put that on the right-hand side. Just, it doesn't really matter, but just to be consistent with how I did it in the last one. So Amanda said the sine 14.886 over C2. And then on the other side, it's the same thing we did with C1. Sine 35 over 6 again. And you cross multiply and solve that. And what will C2 equal? Yep. 6 sine 14.886. Yep. Yeah. That's it. Okay, so just type that in. And that's your answer.
Point out something, earlier in the table, when you were filling out the values, finding whether it's one or two solutions, I found that, if, beta 1 is greater than alpha, then there's a beta 2.
If beta 1 is greater than alpha, then there is always a beta 2. All right, so it could be, we could go, but maybe we'd have to double check and see if that always works. And if it does always work, then maybe we could, at some point, come up with a reason why it always works.
It's just that, considering you're using 180 minus beta 1 to figure out, what beta 2 is, and then beta 1 plus alpha,
well, I think you might be on the right track with explaining why that could work. If you could think about it, maybe you could come up with a shortcut. If you can't, you always just check it the way I did. Because you got to do 180 minus the angle anyway if you're going to get that second answer. But yeah, there's sometimes a little bit of shortcuts or a little bit of reasoning you can do. All right, any questions on the two solution case? So that's the longest case. It's basically what you did on the test twice. All right. And let's look at this one. Okay, is this going to be a law of sines problem or law of cosines? How do I know it's law of sines? I have a row that's complete. What else do I know about it by looking at the table? It is the side-side angle because I have a row with nothing in it. I have no way to find anything in that row until I find something else first. So, what do we have to find first? We have to find alpha first. Okay. How would I set up my proportion to find alpha? Yep, sine 50 over 1 equals sine alpha over 2. And really, we don't even need to cross multiply. Just multiply each side by 2. So you get 2 sine 50. I don't even have to put divided by 1 equals sine alpha. Yeah. And then what would be my next step? Yeah. I'm going to take the inverse sine of both sides. And that's going to get alpha by itself. Okay, so try typing that in on your calculator and see if you can get the answer for that. Okay, and we'll write it down. All right, so what do you get when you type that in? Inverse sine of 2 sine 50 degrees. Anybody have a calculator? You got an error? All right, let's try it on this one. Inverse sine of 2 sine 50. Hey, we get a domain error. Whenever you want to take the inverse sine of something, you can only take the inverse sine of numbers between what and what? Francisco? 1 and negative 1. Well, let's look at what 2 sine 50 is. You're trying to take the inverse sine of 1.5. You can't do that. Basically, it's like asking this question. Where does the graph I just drew, sine, intersect the line that's going to be drawn in a second? Where do they cross? They don't. All right, so you can't. This is a problem that if you actually tried to sketch the triangle, which normally when I have extra time, I actually draw it out and show you, the sides don't connect. Okay, the angle is too big or one side is too short. Something happens that the sides don't connect. So that means you can't find alpha. And what else does that mean? And you can't find beta, which also means you can't find B. Right, so this one, yeah, it's exactly the opposite. It's a lot shorter, and you find out right away you can't sketch it, or you can't solve it. Okay, that's an example of a no solution. Okay, so now you've done the side-side angle case with one solution last week. We just did a two solution, and that's a no solution. All right, so we'll finish up this section with a word problem. And the idea here is we really need to make a diagram. So what we're doing is there's a mountain in the distance. A surveyor is going to take two sightings of the peak of the mountain, and the two distances are 900 meters apart. And what the surveyor is going to measure each time is the angle of elevation. So that's basically like if you were standing somewhere and you had like a laser pointer and you point it at an object, what's the angle that you had to point the laser up at to aim it right at the peak of the mountain? Okay, so the first time that the surveyor does that, he has to point it at a 47-degree angle from where he's standing right to the peak. And then as the surveyor backs up, what would happen to the angle that he would have to point his laser at to still aim it right at the same spot? It would go down, right? Just think about if you're staring at something really close to you, as you start to back away from it, you don't need to look up at it as steep. Okay, so the second time that the surveyor does it, they get an angle of 35 degrees. Okay, the device that the surveyor would use to do it, it's called a transit. And just for our purposes, we're going to assume the transit is level with the ground. If it wasn't, you'd have to take the height that you find and then add the height of the transit in, because the transit might be 5 feet off the ground. But we'll just assume the transit is level with the ground. Okay, so the goal here is basically to find the height of the mountain. So find height of mountain. All right, so as I said, we need a picture. What's something I definitely need in my picture? The what? I need the mountain. What else? The angle will be created from things we draw, but yep, we're going to have to label the angle. So we're going to have to mark a couple spots where the surveyor's standing. And one other important thing. Okay, we're going to label the 900 meters, but something else. Okay, the triangle will be created from what we draw, but if I draw exactly what you've told me, it's going to look kind of funny, because we're missing something important. What are we missing? All right, you tell me what to draw, and I'll draw exactly that and watch what happens. What's the first thing I need? A mountain. All right, so just to make it simple, there's my mountain. I need ground, yeah. So I need a horizontal, like that. So now we've got, the surveyor is going to stand here, then they're going to back up a certain distance. What's the distance between the sightings? 900 meters. Okay. Now, this is the first angle of elevation. That's the second one. And I'm going to put those in as dotted lines. What's the first angle of elevation from where the surveyor stands to the top of the mountain? So that's 47 degrees from where they're standing to the peak. And how about the second time? 35? Okay, so that's my second one. All right, so my goal is to find that. Okay, that line in red is the height of the mountain, not the slant height of the mountain. That's like if you were walking up the side of it. I want to know the actual height. Okay, so any questions on that? So really, the triangle that we want to work with is right here. That's the one in blue is what we really want to be able to work with. The problem is, I don't have enough information to work with it yet. Okay. This is the height. I know this is 47. I know this is 90, but I need a side. So how can I get a side in that triangle working with something else first? Yep, I got to work with a different triangle first. Okay. Where would you go from there? You're not sure. What else can I label in that picture? There's more stuff I can label based on what they gave me. Yep. Yeah. How come? So we have two angles here that form a straight angle there. They're a linear pair, so they have to add up to 180. So this angle here is 133. What else can I label? Okay, I could label this angle. It turns out I'm not going to need it, but I could label it. But what I really need in that triangle in blue is a side. So I've got to label some more stuff in this diagram first, and then I think you'll see a side we could figure out.
You could do the third angle
Can you explain where it is?
in the triangle on the left.
So yeah, the one formed by the dotted lines?
Yeah.
Yeah, because we know we can subtract the 133, and we can subtract the 35. So this angle at the top is 12. So now I want to focus on that triangle with the dotted lines. What side could I find there? Yeah, I could find the hypotenuse of that triangle in blue. I could find that. I have enough information to find it. So let's set up law of sines to solve for this side. Okay, so remember the law of sines. Sine of an angle divided by what's across from it equals sine of an angle divided by what's across from it, because nothing's labeled here. So what could I do? Sine of 12, yeah, over 900, perfect, equals, what would go on the other side? Sure, sine 35, and we could call this side in green x. Solve that for x, and you'll know the hypotenuse of that blue triangle, and then we can find the height very easily. So we get x equals 900 sine 35 divided by sine 12. Okay, so let's see what we get. 900 sine 35 divided by sine 12. Okay, 2,482.9. Let's just round it like that. And I think that was feet or meters? Meters. So 2482.9 meters. All right, so now, how can I get the height of that triangle in blue, which is the height of my mountain? Yeah?
Well, concerning angle on both sides, the bottom side, law of sines, in which if the sine of 90 over 2,482.9 equals sine of 47.
Yeah, you could use law of sines to solve it. That would work perfect. Can anybody think of another way to solve it without law of sines? That would work. But what kind of triangle is that? It's a right triangle, so you don't need law of sines. What could you do? If you want, well, we don't have two sides out of three, otherwise we could. How would we set up an equation? What trig function would you use? Yep.
Sine,
Yep. Sine of what?
47,
Yep. Equals
h over 2,482.
opposite over hypotenuse. Exactly. So just multiply each side by 2,482.9, and that is your height. Without having to use law of sines, I have a feeling if you did use law of sines, that might have been the calculation you'd have to do anyway. We just simplified it a little bit. Is that right? Yep. So the height of the mountain is 1,815.9 meters. Okay, so a little bit of a multi-step problem because you had to find one side first to get what you really wanted, which was the height. But it all boils down to basically creating a triangle, or in this case, multiple triangles. Okay, and if you really wanted, you could find the slant height of the mountain, assuming the mountain was perfectly triangular. But that's all they wanted us to do. Any questions on that? All right. So we'll finish up with the last law, which is the law of cosines. And it's just a slightly different formula that allows us to solve two additional types of triangles. Bless you. Okay, so we've done this. Side angle, 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 side angle, and all three cases with side, side angle. Now, law of cosines is going to enable us to solve these two types. Side angle, side, and side, side, side. Right, so we'll do one example of each type. And then we'll try to look at one other topic as well, which has to do with how to find the area of a triangle. And it's related to law of cosines. You'll see how. Any questions on what the law of cosines allows us to do? You don't have to draw these diagrams if you don't need to. I'm just trying to show you what side angle side and side 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 looks like when you're given a problem. All right, so here's a problem that we would need law of cosines for. Why can't you use law of sines? Just looking at the table. You don't have a complete row. So no matter what you pick for law of sines, you're going to be missing two pieces of information. You can only be missing one. Okay, so there's three versions of the law of cosines. And the first one starts out like that. What does that look like? Yeah, it's Pythagorean theorem, but remember, these are not right triangles, so there's an adjustment on the end because we don't have a right angle. So it's one side squared equals the sum of the other two minus twice the product of the other two times the cosine of the angle across from the side you started with. Now, I want you to see what happens if you use this law on a triangle that does have a 90-degree angle. So let's watch what happens if I type cosine, and let's pretend we did it with a 90. The cosine of 90 gives me what? 0. And what's 0 times anything? 0. And if you subtract 0, does that make a difference? No. So if you use this law with a 90-degree angle, that part on the end disappears, and you just get your Pythagorean theorem. Right? Now there's two other versions of the law, following the same pattern as up above, just starting with different letters. Anyone think they could give me the version that starts with b squared? Nope, same pattern as what's above. Unless, do you see a plus, a negative up above? Nope. We're going to follow the exact same pattern, just we're going to put in different letters.
A squared plus c squared minus 2ac cosine of a.
Yep. That's the second version. And how about the third version? Yes. Okay, which version you use depends on what you're given. If you have a side-side-side problem, you could use any version. Because in a side-side-side, you would know every letter in every formula, right up to where I just put that dotted line. But if you have a problem like I have here, this is a side angle side, you have to use a certain version first. What version would I have to use first in this problem? 1, 2, or 3? Why 1?
Because you have the angle to C.
Because I have gamma. Yeah. The problem is you're already missing C. So no matter which version you pick, every version has a C in it. So you can't be missing anything else. Right? So if you picked the second or third version, you'd also be missing alpha or beta. So you've got to use version 1. All right, so version 1 says C squared. And I'm going to do some of it as I go. What's A squared? 16. And then plus B squared minus 2 times A times B. Well, what's 2 times 4? 8 times B? 56. Cosine gamma. Okay, what would I do next there? Oh, and gamma we know is 42. Sorry, let's fill that in. Yeah, if you know something, fill it in. Yeah, what would I do next? Okay, we can do the multiplication. What are you going to multiply?
56 times
All right, so we've got 56 cosine 42 gives me 41.61 or 62. All right, and you know what? Let's go 3 decimal places. 616. To be a little more accurate. All right, so next, just do out that arithmetic. So 16 plus 49, and then minus 41.616. That gives me 23.384. But what's my last step? Yeah, take the square root, and that's my answer for C. So it's about 4.836. Now, you have a row with everything in it. But the problem is, if you sketch this out, the information that you're given, it's going to be a side-side angle triangle. Okay, before it was a side angle side, so we use law of cosines. It's also a side-side-side now, so we know all the sides. That's still law of cosines. But it's also a side-side angle. Why do you think I want to stay away from using law of sines, specifically because it is side-side angle?
Because we found C, and if there's an error,
True, we found C, but unfortunately, we're going to have to use C to find beta. So if we got C wrong, then we're also going to get alpha and beta wrong. But that's usually a good reason why we want to be careful. But what's another reason why I want to stay away from side-side angle?
Side angle is multiple solutions or no solution.
Right. If I try to do this as a law of sine problem now, I have to deal with the 2 solution, no solution stuff. Right? If you sketch it out, you would see. So let's do law of cosines one more time to find alpha. Or you could find beta. It doesn't matter. Okay. How does the law of cosines start out when you want to find alpha? A squared, right?
B squared plus C squared.
Yep, A squared equals B squared plus C squared. So 16 equals 49. Plus, what's C squared? Right there, 23.384. Minus 2 times, and what's B again? 7. So 2 times 7 is 14 times C. I need to do that out. So 14 times 4.836 gives me 67.704 times the cosine of alpha. Okay? What would we do next? Yeah, combine like terms. What can you combine? Yep, you can combine the 49 and the 23. That gives you 72.384. Now, can I subtract the 67 from that? Right, this equation is really just like this one. You can't do 72 minus 67 because you're multiplying 67 by something you don't know. So next, we have to bring something to the other side. So what would I bring to the other side, and how would I do it? Yep, subtract 72.384. So we get 16 minus 72.384. That gives me negative 56.384. And that's negative 67.704 on the other side. Two steps left. Yeah, so what I'm going to do is I'm just going to go like this. I'm going to divide each side by the negative 67. So that's gone. And that's gone. And my last step. Yeah. Take the inverse cosine on the left and on the right. So it's the inverse cosine of 56.384 divided by 67.704. So we get 33.612 for alpha. Now, you could do the same thing to find beta, exactly the way we found alpha, but keep in mind, you already used something you calculated to find other things. You had to. So at this point, I'm just going to subtract 33 from 90. I'm sorry, 33 plus 42 from 180 to get the other answer. So minus 33,612 minus 42, and I get 104.388. Any questions on that one? Okay, so that's a side angle side. And side angle side has one of each types of things you have to do with law of cosines. Okay, one type of thing you have to do is take the square root at the end. The variable is pretty much already by itself. The other type is when the variable is in with the cosine function. Okay, so side angle side covers everything you'd ever have to do. Side, 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 you always have the variable in the cosine function. So side, side, side is basically like doing this right there. You're always finding an angle. How many times are you going to have to do law of cosines at a minimum here? At least twice. But what's nice about side, side, side is you can find alpha, beta, and gamma all separate. So a mistake on one part doesn't affect anything else. But what I'm going to do to save a little time is I'm just going to do it once. You would have to do it a second time. And then what would you do with those two angles? Add them together and subtract from 180. Okay, so let's pick an angle that we haven't done yet. I think we found alpha last time. So do you want to do beta or gamma? Beta. Okay, so how does the law of cosine start out with to find beta? So b squared, yep. A squared plus c squared, yep. 2a, what is it? Nope, not 2ab, 2ac. Yeah, so 2 times, let's do c first. What's 2 times c? Times a. 90 cosine beta. All right, if we add 81 and 25, that's going to give me 106. It's nice when they give you all the sides because you don't have any decimals to work with. Next step. Subtract the 106. That gives me negative 57. 2 steps left. Divide by negative 90. And I can cancel off my negatives. And inverse cosine. That's the exact set of steps you would have to follow one more time to either get alpha or gamma. So second, inverse cosine, 57 divided by 90. So 50.704. Okay. And that's how you do a side-side-side problem. Just do exactly this one more time. Doesn't matter which angle you pick. If you want to be really sure you don't make a mistake, do it 2 more times, if you have enough time. If not, just subtract the 2 you get from 180. Okay, so that's a side-side-side problem. You never have to take a square root in a side-side-side problem, because you're never solving for a side. Let's just set up the, I want to show you the diagram, but we're not going to go through it. Okay, the idea here is a surveyor is measuring the distance between 2 points, A and B, and they're on opposite sides of a building. Okay, the surveyor measures the distance from point C to point A and from point C to point B. And the idea is to find the distance between points A and B. What kind of triangle is that? In terms of the three letters. That's a side angle side. And what law does side angle side fall under? Law of cosines. So if we call this side x, remember, law of cosine starts out 1 side squared equals the sum of the other 2 squared. So how would that start out?
X squared.
Yep. Squared equals 110 squared plus 160 squared. 2, 110, 160. Cosine 54. There's your setup to solve the problem. And this is one where you're going to take a square root in the end, because you're solving for a side. You're not solving for an angle. So you basically just have to type that in. The numbers are going to get a little big, but that's how you would solve it. Any questions on that? Okay. All right, and the last thing I'm going to show you is a different formula to find the area of a triangle. Okay, and the formula is, in general, it's half the product of the 2 sides times the sine of the angle between the sides. Okay, half the product of 2 sides times the sine of the angle between the sides. The 1/2 comes from the basic formula for area of a triangle, half base times height. But the other part, where the sine comes in from, it has to do with looking at this diagram and making a substitution for height. Okay, and the way you do it is you just look at one side of the triangle, and you basically can write a trig function with the 3 things I just circled. Sine of alpha equals opposite over hypotenuse. Opposite over hypotenuse. And then if I solve for the height, I get C sine alpha equals the height. And then, if you take C sine alpha, that's the height, and replace it right there, you would get 1/2 B, that's your base, times the height, C sine alpha, C sine alpha. So it's just basically a different way to find the area of a triangle. So when nothing's labeled in the picture, you just have to understand the general idea. 1/2 the product of the 2 sides times the sine of the angle between the sides. Okay, so how would I find the area of this triangle? Yep, 1/2. 1/2 the product of the two sides.
And then the sine of whatever the angle is.
Yep, 105. Now, why didn't I just do 1/2 base times height? I don't have the height. Right? If I did, I could have just used the basic formula. Okay, so all you have to do is type in, that's 3 times 12 is 36, half of 36 is 18. Type in 18 sine 105, and that's your answer. Just remember it's area. So you should always put square feet, square inches, square units. Any questions on that? Okay, and the last type of area problem gives you 3 sides. So let's say this side is 9, 7, and 5. Can you use 1/2 the base times the height here? No. Can you use the formula I just taught you directly? No, because what are you missing? You're missing an angle. How many angles do you need to use the formula you just learned? You only need 1. How could you find an angle in this triangle? It's the law of cosines. It's just like this problem. It's a side-side-side problem. Use the law of cosines to find one angle. It doesn't matter which one you pick. And then, after you have that one angle, let's say you get this one, then just type in 1/2 the product of the two sides times the sine of the angle that you found. Okay, so side-side-side is a little bit extra work because you have to find an angle first and then use the formula. So any questions on that? All right. Okay, so the homework on 435, that's law of sines. It's 5 questions, 4, 9, 11, 13, 18. And then on page 443 is law of cosines. It's 2, 5, 6, 13, 14, 17, and 19. Okay, and in the book, every side-side-side problem they give you for law of cosines, there's no solution. So I wanted to make one up that actually worked, and that's why I wrote this one down. Remember, a side-side-side problem won't work if you add up 2 sides and it's not bigger than the third. And the book does that on every problem. Okay, so that'll be due on Wednesday.